People talk about power supply failures or any product, they call it the bath tank curve. So meaning we have many failures in the beginning, then there's a very low failure rate, and in the end the failure rate will come up again. So how does your bath tank look like? How steep is it in the beginning, and how far away is the end of the bath tank?
How do you handle communication with engineers, either on the supplier side or the client side?
Yeah, so for the power supply level, one of the major points of contact, besides the electrical and mechanical specification of the products, are about the safety and EMC compliance documents. And there are standards. And the good news is that in China, where most of the production happens, there are also qualified and accredited laboratories that provide third-party measurements for them. I often like to accompany them there so that I know there's no fake around, because there are stories in the market where they have a golden sample in the shelf which passes the test, but the rest doesn't.
Right. So even a third-party verification could be compromised.
Yes. So if you really want to make sure that you really have a serial product in the laboratory and not a specially tuned product, the only way to really ensure this is to be on the ground when the test happens.
Wow. Okay.
Yeah.
And then, so what are you doing?
And then we communicate that report to the customer engineer or the customer side. And on the supplier side, as most of the engineers, as you say, usually do not speak English. So you have to have a Chinese-speaking person on the ground.
Okay. Yeah. And then, so your team are multilingual?
Yes. In our team, every employee speaks at least 3 languages.
Which are the main 3 languages that are necessary?
Well, number one, number 2 is always Mandarin and English.
Right.
And then we have a third one, which is usually the joker. So we have a Malay-speaking staff, we have a Thai-speaking staff, we have a Polish-speaking staff, some Japanese, Taiwanese.
German.
German, yeah.
Yeah. Can you share your experiences dealing with electromagnetic interference?
Yeah, well, in electromagnetic interference, so there's 2 things. One is that your own product is not allowed to emit certain level of radiation. That's the EMC. And then the second one is that your product is not allowed to be cannot be disturbed too much by external interference. So that level is higher. And then we distinguish usually in the way whether it is an industrial application where you can emit a bit more, or a home application, or in a normal residential setup. In a residential setup, the requirements are more stringent. There, because you don't want to have your product to interfere like with your TV and your other appliances. And then there are some special professional environments, for instance, in the medical field or in the, let's say, the marine environment, where you have some specific areas, for instance, where you have to be very low emission. For instance, on ships, they have these walkie-talkie frequencies, which the people need. So any electrical equipment which is used in marine cannot emit things on the frequencies where the people use the walkie-talkie. So they have a special frequencies where you have to particularly pay attention to. So this is for your own emissions, which are tested in 2 ways normally. So you have the lower frequency range from 9 kilohertz to 30 megahertz, which are, if it's a power conducted component, it's measured on the power line. So you have an artificial grid simulator, and you measure the emissions on the line up to 30 megahertz. And then above 30 megahertz, now to I think 4 or 8 gigahertz, you measure in a chamber. So you have to go into these chambers where they have an antenna. Usually it's a 3-meter chamber, and then this antenna will measure the vertical as well as the horizontal frequencies, and the product is on a turntable and is turning around to see that you're not emitting into any particular angle emissions. And that's for your own field emission. And then you have the immunity So immunity is like, for instance, that if there is somebody is like, when you're like on a carpet, for instance, and you're electrically charged, you sometimes have this, like when you touch a handle on or your faucet in the bathroom, and that you see sometimes a little arc, right?
Right, get zapped.
Like a little zap, right? So now you want to make sure that your product, when somebody is charged and you discharge onto that product, it doesn't fail. So they have these discharge tests.
Wow.
On the product, and there you go two ways. You have some products which have like a conductive surface, like with a metal sheet, like your PC, and then you have non-conductive sheets. So it's a plastic housing, for instance, and there are different requirements. And you also put pulses onto the power lines to see if there is like an arc coming onto the power line, because maybe there's like a flash or like a thunderstorm or there's something coming into your grid, in your home grid, and it shouldn't destroy your product. Of course, it's not indefinite, but there are simulations for this, and there are norms, and these have to be tested. And normally this happens in laboratories, in external accredited laboratories.
And then, so are you involved in this whole testing process?
When I'm in the development, that's one of the key elements, before we release the product, yes.
Okay. So your clients can be sure that they won't encounter any EMI issues?
Well, this depends on the application, but of course you have to verify this.
Yeah.
But you can only do as much as the client provides to you.
Right.
So you have to agree on a setup which represents the common use of application, because EMI differs quite substantially whether your power cord, the length of your power cord. For instance, if you have ever wondered when you buy a printer, why the power cord on the printer power supply cable is only that short?
Yeah, why?
Well, because it's easier to manage the EMI when the power cord is this and not that. So they were saving money, so in order to be compliant, they give you this power cord. They all know that you're going to use a longer one, but then you won't be compliant.
So it's not about saving money, it's about being compliant?
Yes, saving money in the components in the power supply, so they can make it cheaper.
Right. So
Because if they want to make it for that cable, they would have to put more components inside.
Oh.
So
Yeah.
So that's why. But they have to offer a compliant solution, and it's easier on a shorter cable.
So the main challenge, as I understand, in sourcing power electronics is all about this compliance and EMI and things,
reliability.
And reliability. What are the reliability issues that can happen?
Well, in most power supplies, you have storage capacitors. These are these little round cylindrical shaped metal parts called electrolytic capacitors. And there's a liquid inside. And over time, this liquid will dry, and that capacitor will lose its capacitance. And when the power supply relies on the intermediate storage in this capacitor, eventually it will die. No power supply will live forever.
Right.
But how long is long enough?
Yeah, so what should clients expect?
Okay, so for the standard that we see often is in commercial, like a normal consumer level power supplies, you often see like 20,000 to 25,000 hours. But when you're in industrial spaces where you need longer, you need different things. The second one that you need to look at, so coming back to the electrolytic capacitor first. The drying process very much depends on the temperature. So if the temperature is low, the drying is slow. When the temperature is high, the drying is fast.
Okay.
But how hot is it inside that power supply at that point? So I have to consider.
Right, some power supplies get very hot.
Yes, you can feel that, right?
Yeah.
So, and then there are regulations that you as a human body, a human person, you can only touch certain materials up to a certain temperature. So for instance, metal surface, you should never be more than 60 degrees, not to burn your finger.
Yeah.
And for plastic parts, you can do higher. But again, inside you cannot be too high, otherwise your power supply won't last as long. And then the second one is like, for instance, when you're in a PC, you hear there's a fan normally in the PC. And any moving part will also not live forever. So the fans will eventually die. First they become noisy and then they will die.
Yeah.
I think everybody has experienced this. For instance, also your fridge also has a fan, right?
Mm-hmm.
And after time it will start making some quirking noise and then at some stage it will die. So lifetime of fans is also a critical part.
And these fans are inside the
Yeah, it can be
power
inside the power
supplies.
supply. If you're in your PC, you have a fan.
Yeah, yeah.
Yeah, and that's why they won't last for more than 10 years. This is
Mm-hmm.
quite clear, but sometimes you can change the fans. So when you have an industrial application, you need to understand your requirements. And you have to understand the service part of it.
Mm-hmm.
What part is serviceable and what part is not serviceable.
Right.
So for instance, server power supplies, like for those in the data center, they are so notorious that they often put redundant power supplies inside. They put 2 power supplies inside because they already know one will fail.
Wow.
And they will alarm the system so that the server will not shut down.
Mm-hmm.
So they can service it.
So for people looking to source power supplies, what are the typical scenarios? I know some products come with built-in power supplies.
Very common.
In this case, should clients do a lot of due diligence before buying
Absolutely.
with just the power supply?
Absolutely.
Because I could imagine, let's say I'm sourcing LED lighting and I'm focusing a lot on the lighting characteristics or specifications. Meanwhile, the power supply, I might just assume, oh, it's just a power supply. What could go wrong?
Mm-hmm.
But have you seen this attitude, more or
Yeah,
less? Yeah.
well, until they suffer, right?
Right.
So yeah, I mean, in the LED lighting, you have always LED drivers that provide the light source with the necessary current. And actually, they're often even more vulnerable to failure than the LED light itself.
Wow, yeah.
And because in lighting, there's the additional situation that it's usually not with a fan, because you don't want to have a noisy lamp, right? So when you don't have a fan, you have to consider your cooling.
Right.
And a lot of inexpensive lamps have a very poor cooling, which will come to the result that eventually the power supply will fail.
So is it safe to say that as long as you're trying to cut your costs on a power supply, you might pay for it over the long term?
Yes, because for the question for the power supply maker is, who pays for it?
Either they pay for it or the client.
Yeah, they never pay for it.
They never pay for it. Yeah.
Yeah.
So, okay, so then it's actually quite a complex and so-called boring topic.
Yes.
That it may not get enough attention as it needs, this idea of how to source power supplies. What is a framework that people should follow when they are having the initial conversations with suppliers?
Okay, so power supply reliability and engineering effort usually pays off when you have a product that is in frequent long-term use.
Mm-hmm. That's like universal for every product.
Pretty much. However, in lighting in particular, the use case tends to be longer than in other cases. Or to give you a very simple example, if you think about your hairdryer is also converting the electricity into the fan speed and a heat coil, right? But how long do you use your hairdryer every day?
At least an hour for me.
You? An hour? I don't think so. Not with your hairstyle. So,
the typical woman, I would say 30 minutes. I don't know, to the woman in the room.
I would say it depends on the length of the hair, but
Right.
I would say let's settle down on 10 to 15 minutes.
Okay, I
Yeah.
was way overestimating. Yeah.
Oh yeah, I think so. So given the situation that this hairdryer is only used 10-15 minutes a day, then this is maybe 35-36 hours a year, maybe 100 hours in 3 years.
Mm-hmm.
So the power supply performance does not really matter.
Right.
Okay, so for that product, you will probably not spend so much time. Now we take the other extreme. We are selling power supplies for water treatment equipment, which is used in salmon farming.
Oh, wow.
So there they pump the water into the salmon farm through a pipe where the bacteria is killed by UV light, and that lamp is using 24/7.
No days off.
No days off.
Yeah.
On all the time. Yeah. So that's 8,190 something hours a year. Very different from the 36 hours that is on your hairdryer.